Hello, so glad you could join us for another Coffee Break Tech Talk on Digital Trust. I'm June, and with me today are Michela Menting, Digital Security and Blockchain Research Director, ABI Research, and David Nelles, Deployment Architect, NetGuard Endpoint Security, Nokia. We're going to unpack the topic of endpoint security and device protection in the Internet of Things. Hello, Michela and David, welcome.
Thanks for having me.
Hello.
Hi. So I'm personally a big fan of smart home technologies, and you won't be surprised to know that my favorite involves coffee. So I recently bought a device that lets me control my coffee maker with my phone. It's the first button I push when I wake up, and by the time I'm down in my kitchen, my morning pot is brewed. Now, that's a very simple action, but I'm wondering, as more mobile solutions like these come online for our homes and businesses, how do we make sure the devices aren't being compromised?
That's an important question because we're using, smart mobile and IoT devices for everything from entertainment and fitness to healthcare and financial tasks. On the industrial level, IoT devices are being integrated into the way that industries and cities operate. Enterprises are digitizing their processes, their operations, and they're deploying IoT, AI, ML, and 5G today as well, among other technologies. Now, ABI Research, we predict 23.6 billion IoT connections by 2026.
Right. And so as you can hear, the volume of devices to be protected is like staggering. Smartphones have sold over 1 billion per year for the last 8 years. So this just means an overall expanding threat surface. It's just getting larger.
Okay, this is really interesting. And so the threat surface is growing, but what are the threats exactly? What are we talking about?
So people often talk about mobile and IoT security as though they were a monolithic or a homogeneous thing. But really, in fact, it depends on the kind of device that you're talking about, right? There are two main device classes, broadly speaking. On one side, we've got simple, low power, sort of single function devices with constrained or restricted capabilities. And on the other, we have mid-range and smart devices that are multifunction, that are well-resourced, with longer range communications than their constrained counterparts, and that can run simple operating systems as well. Now, a good example of a simple type of device would be any kind of sensor, really. But, we can think about power or smart meters as well, or temperature sensors, if you will. On the other hand, wearables, SCADA systems, connected devices, these kind of fall into the more complex category. And essentially, they're fully functioning computers, right? So compromising these can have potentially nefarious and serious consequences for individuals and industrial applications alike. So the threats are different, right? With sensors, an attack may damage it, may knock it offline. It could, affect the overall safety of whatever's being monitored. Batteries can be drained, devices can be hijacked. But because more complex devices, they're used for different types of tasks, right? The attacks often target the information that's exchanged between them, right? So the data and the transactions, they can be intercepted, they could be observed and stolen, they could be manipulated or used maliciously, if you will. And even services such as SMS or MMS, they can be used really in unauthorized ways.
Yeah, that's exactly right. The security really depends on the device being secured. IoT devices are critical to industrial applications. For example, gas line pressure, temperature, vibration sensors. They're all required for the safe delivery of energy all over our countries. Mining and fleet operations require telemetry for vehicle safety. So when there's a breach of a device and it's compromised, the entire environment may have to be shut down to ensure a safe place. So that means a mine shut down. That means a gas line shut down. So every device needs to have a security practice applied to ensure correct operation.
Okay. Oh, interesting. So if the different device classes have different security needs, how do you meet them? David?
Yeah, so you're right. Each class of device has its own set of resources that can be used for security. So obviously, smarter, more sophisticated devices with the higher processing power can do more on this front for themselves. So smartphones, for example, can be used and they can be secured with antivirus applications actually on the device. So it sounds like a great idea. However, the number of mobile smartphone devices with actual antivirus detection on them is much smaller than a home PC. Everyone has antivirus on their home PC, not so much for the mobile devices. Now, on the other side, simple IoT sensors are very hard to secure because of their design. They usually don't have the resources, the system configuration, or update capabilities for antivirus applications. So it really does reduce the capabilities of those devices for on-board protection.
That's right. And on-device security applies really only to those devices that can support it. So complex devices that can support runtime protection and monitoring, antivirus, or secure execution environments, they're really not all that common. There are upfront costs, right, to integrating on-device security, and these can vary significantly depending on the context and the application. And this really makes security all that more difficult to achieve. That said, network operators and mobile device manufacturers, they're looking at what the network and the device can each provide from a security perspective. For mid-range smart devices that are more computationally capable, for example, the options for on-device security can include secure operating systems, trusted execution environments, also known as TEs, secure virtualization technologies, right? At ABI Research, our research shows that smartphones are primarily the target market today for TEs, so over 95% of device shipments in 2020. But increasingly, we're really seeing TE showing up in other smart devices and the microcontroller units of constrained devices. So, our forecasts show that by 2025, TE-enabled processors and microcontrollers in terms of shipments will account for almost a quarter of that total IoT segment.
And David, you were saying earlier that while antivirus can be deployed onto smart devices, it often isn't. My sense is that in general, while there are reasons and methods to secure mobile devices, it often isn't happening. Why is that? David?
Yes, exactly. So as news breaks about smartphones and other devices being compromised and how that leak is then being consequently exploited, people are becoming more aware and interested in securing their devices, but they don't want the security to come at the expense of functionality of the device or battery life. So security of each class of these devices will depend on two things: the actual urgency of the severity of the security requirements and the market acceptance of the trade-offs, if there are any. So security as a service is going to be an option for specific types of devices. This is gaining traction in fields such as critical infrastructure, such as power grids and pipelines, which need to be secured from malicious actors. So device managers and network operators are looking to deliver automated security features for both simple and complex devices. So device security can be offered then to these device owners as a premium network service operating. So it addresses these security requirements being placed upon these environments, such as power grids and pipelines.
I think also that in many cases, the biggest obstacle holding back mobile and IoT security is really money and lack of mandate, right? Partly because creating secure IoT devices is really not easy. It often requires a concerted effort across various technology fronts, systems, devices, networks, infrastructure. And there's tremendous diversity across those different domains, depending on the target market and the use cases, right? You compare automotive to smart home to healthcare, for example. There's a lot of complexity there. Most device manufacturers, have the ability to create secure devices, but they haven't really succeeded very well in conveying the value, the true value that secure devices can offer.
I assume that on-device isn't the only option, that protections can be built into the network as well.
Yeah, that's right. So security in cellular networks can be undertaken in a number of different ways, right? You can use security protocols such as cryptographic functions or encryption capabilities to enable authentication, confidentiality. But really beyond that, you can also use network security tools to inspect the traffic for anomalous or malicious activity and try and prevent that as well.
There are significant opportunities for service providers in this area as well to offer managed security as a service. So operators are able to provide security reports and autonomous mitigation methods for attached devices to those networks.
Well, that's fascinating. So if I were to sum up, endpoint and device security are a big deal in the Internet of Things, but security looks different depending on the class of device you're talking about. Simple sensor versus complex smart machine. And it sounds like there's still a lot of room for exploration and innovation in this area, along with some growing demand. It's an exciting space for sure. And now I want to thank you both, Michela and David, for taking the time to share your thoughts and insights with us.
Thank you. It was my pleasure to be here today.
Thank you. It was good.
Okay, and to everyone watching, I hope you'll join us again for our next Coffee Time Tech Talk. See you soon. Goodbye.